Hi, I'm Adam from One Commons, and we are a project dedicated to building a free and open cloud. So, what does that mean? So, imagine just like with open source code, free code, you can take it, it's free to use, modify, fork as you like. What if you could do that with like a live website? Go check out, look at how it's built on the back end, fork it, make changes, rerun it yourself. And so that's the vision behind what we consider a free and open cloud, basically giving you the same freedoms that you have with open source code with actual cloud services. And so why do we want to do that? I mean, basically the reality is everything is moving to the cloud. More and more our lives just depend on services running on the cloud. It's harder and harder just to like run your own open source software yourself. And basically nobody wants to run their own software. Nobody, certainly not their own hardware, their own servers. It's so much easier to get started with a cloud service. The costs are generally a lot cheaper in terms of usage pricing without having big upfront costs. And so that's really putting open source software at a disadvantage. Again, people just aren't running open source software themselves. It's hard to take the effort. And it's also, for the bigger open source projects, it's undermining their business models. So we are starting to see a project shift away from pure open source licenses, like you see that with MongoDB or Elasticsearch, and the big cloud providers are just undermining the basic ways that a lot of these open source bigger projects are funded. And so, our goal, we think there's a way that you can have your cake and eat it too. That we can have a free and open cloud where you get the ease and simplicity of using the cloud and cloud services without giving up the freedom and control of open source. And that we call that open cloud services. And it's easy to think of. So if you just look at, say, the Open Knowledge Foundation has this definition we see here of what openness means with code and with data. And so we can see the same thing with we just apply the same thing with a cloud service, and with the idea that the only limitation around the openness is, of course, preserving your own data, preserving your own privacy around your data and your sovereignty over your identity and your data. And so that's our notion of open cloud services. But a cloud service is more than just code. We know that. So it's if you think about running a cloud service, you both have the code and then you have the data that runs on it. That's either created by the service or given by the user, and then finally, your service is running somewhere, and so there's this hosting component. And so if you think about openness, for something to be truly open, for a cloud service to be truly open, it's both the code. So we can look at this as these different levels. So we think of it as different levels of having an open cloud service. And level one is just the code. So take an example like WordPress. WordPress is open source. WordPress.com, the cloud service is not. So that's, you can think of that as level one. When you add open data, well, then you look at something maybe like Wikipedia, where it's both the code is open and the data is open, or OpenStreetMap's another example of that. And then finally, the third one, we actually have open hosting or free. You have freedom hosting where you can run the service anywhere. It's not tied to a particular thing. And that's where the decentralization and the Web3 technologies come into play. And that's why we're here in this track. And so those are examples, like, for example, like Git as a service. I can run a Git server for serving my code. That's completely decentralized. They communicate. GitHub, of course, is just not open service at all. It's closed at all levels. Matrix, which we're using here at FOSDEM, that's another example of a level 3 hosting service, in that we could run the code and control the data and run it wherever we want. So that's how we're breaking it down. And so talking about, again, so what do these freedoms and this openness give you? And so one way that we think about it, and one big motivating factor behind what we're doing, is that those freedoms give you a certain resistance. I don't know what you can call evil resistance. So we, some of you probably remember a few years ago, a large corporation, you might recognize their colors there, had a motto, "Don't be evil." At some point, they decided that wasn't them anymore, so they dropped that motto. But you know, if we could if you could build a service that guarantees these freedoms, and you have this resistance, so it can't be evil. Well, I mean, of course, there's lots of ways to be evil in this world, but we have these limitations, and that's one of the reasons why most of us are really excited about Web3 is that the protocols provide you with fundamental guarantees over the data, et cetera. And so if we could build that into these open cloud services, that can make a better internet and a better world. And so let's kind of break down what we mean by these different levels of openness. So code, start there. We're all familiar with this. This is open source code and free code. And so, the Free Software Foundation, Richard Stallman, when they came up with this, they decided there's the 4 freedoms that underline free code. And one, the first freedom is just being able to use it. And so in the context of open cloud services, it's being able to run the software, being able to modify the code, being able to freely share the code, and then finally being able to share what you modify, which is what we call forking. And so those are the 4 basic freedoms that underline code. So if we apply that again to the next level, to data, then we start seeing freedom of access. That's like the data portability movement around open code. If you want to be able to modify data, then you have to have interoperable formats that are extendable and interoperable. If you want to share it, then that's where open data licenses come in. But then you also have to have rules and licenses that preserve privacy for sharing to work. And then finally, remixing, forking. That's where you need more than just the data. You need APIs that enable different services to combine and expose the data they're creating. And so the final level is hosting. And again, this is where the decentralization technology comes in. So at the most fundamental rate, if you want the freedom, another way to look at, so the first freedom was for developers around code. The second freedom is more around users. These are the freedoms for the data because it's their data. The final one for hosting is more around people running the services. If I want to run my own service, I want to be able to do it on my infrastructure, and I want that freedom. And so if you look at those different freedoms, one is simply being able to access it and run it. And so that's kind of like reproducibility. You need to have a way to take a service and run it somewhere else. And then second is when they modify it, not having that code depend on other proprietary services, being tied to a particular proprietary platform. Sharing, this is where the concept of federation comes in. So email, classic federation, email servers talk to each other, they can share the data, Jabber for chat. And then finally, the concept of remixing, we can map to the idea of full decentralization, where, again, classic blockchain protocol, so a financial transaction, everyone access to that. It's or peer-to-peer. They have complete interoperability as long as every piece of blockchain is decentralized. So that's another example of giving all those freedoms, those different levels for hosting. And so, but if like the blockchain is around a particular type of transaction guaranteeing that data is available to everyone and that we can trust it. But if we're talking about open cloud services, we're talking about things that have to work with the protocols we have today. You have a web browser, it talks over HTTPS to a server. And so to guarantee those freedoms, just like all these freedoms, you have to have some way to trust it. So if I can't trust the service I'm talking to, and because it's anyone's running it, we're not going to be able to get there in terms of building something that's truly open, these cloud services. And so just kind of breaking down how we can get there. So today, you basically, for most of us, we just are trusting whatever's on our machine, our laptop or desktop, whatever software is using there. It talks to some server out there. We don't really know. It's a black box what it's doing. We just have to place trust that they're going to do the right thing with our data, that the code is doing what it says it does. And then in turn, the person running that service, the company running that service, is trusting the hosting provider that they're running on the cloud provider, that they're going to run their software that was they're going to run their server as they claim they will. And so, but this kind of exists today. It just would take a lot of effort to do it. Today, if I run, a pure open source operating system like Linux on say a laptop that has like a secure boot technology, and then I'm running like a Chromium browser, a Gecko browser, a Mozilla browser, I can basically have assurance that I know that exactly what code is running on there, and I can trust it. And it can, on the other hand, what's being introduced with the big cloud providers like Google's Titan chip is this ability where they can guarantee that your compute workload is running on their machine, and you can have remote attestation where they can go out and talk, and so you as the application provider running your service can really trust your code is running as they say on their cloud provider. And so there's a lot of work going on. So, but in between that, we still don't know, and that's where open cloud services come in. So the technology, if you could create reproducible something that's open, so it's all open source code, and there's reproducible infrastructure, so we know exactly how that is being built into a container, and we use these technologies on the other end. Now we can start to have assurances that no matter where it's running, it is what it says it is. And for the data, we can rely on other services like HoloChain, example of something that you can rely on in terms of relying on the data. And then so what we need to do for this to work is to build a protocol so that your browser, when it talks to that application that you're connecting to, it says it is what it is. It's running exactly what it says it is. And we're not that far from being able to do that, because we can add an extension to the TLS protocol that, just like today, they have certificate transparency, that can these protocols to see that those certificates are what they say they are. We could do something similar with remote attestation, where we could say we put the remote attestation from the server hardware on a blockchain and use something like certificate transparency, so that the protocol, when your browser connects, it can actually verify that this hash being sent through the protocol is what it is, and corresponds to this chain of reproducible source code running your application. And so once we do that, now we have this freedom to trust that different people running different services are ones that are running what they say they do and are conforming based on the fact that the source code is open. They're conforming to whatever licenses around your data usage you have. And so that's how we think we can get to this vision ultimately. And then the next step, and the next part of this getting there, is of course fundamentally running a service consumes resources, it takes money, and or something like money. And so we have to have a way to fund that, or else there's not going to be very many open source services out there, open cloud services, if there's no way to fund it. And so funding is obviously a tricky thing. Funding open source has always been sort of a holy grail, a thing to kind of figure out. But one thing we could step back and think is, there is something like $300 billion a year being spent on the big cloud hosting providers to host infrastructure, to host software that is almost all of it is in some way or another depending on open source code. And so if there is a way that just even a tiny percentage of that infrastructure spend can go to funding the open source projects that they depend on, then that would transform the open source ecosystem. And so this idea of coming up with what we call cloud funding, a mechanism to do that doesn't undermine open source, an open source model, is crucial. And so some of the requirements that any kind of system we build has to do is, one, it has to be freedom preserving. It can't undermine open source, so it can't create a barrier because you have to pay for it. Then that's obviously completely contrary to the idea of open source. Any kind of funding system has to be fair and equitable, or else, again, it will undermine any kind of motivation to contribute to an open source ecosystem. And as a corollary to that, I think it has to be simple and intuitive to understand for people to perceive it as fair and equitable. It has to be efficient, obviously, so that it funds the right things, and it has to be resistant to gaming and perverse incentives and not create its own set of problems. And so those are a big set of requirements. And so I'll just throw out a straw man of what we're working with. And so just to break it down, so imagine if developers, and whether they're open source projects or open cloud services, they could register their projects, say, what kind of funding needs they need and why they need it. And then when users go and deploy through a service that supports this, then they can say, hey, I want some small percentage, some sort of gratuity of what I'm spending on my hosting bill will go into this pool of money. And then the key here is the users choose what projects they want to support. So it becomes a voluntary thing, just like open source is a gift economy. And then and the key mechanism here is then those projects also in turn pledge to give back of the projects that they in turn depend on. They choose, okay, these are the ones that I support for whatever reasons, and then they pledge to give away a portion of that, and then so on. If another project receives this, then they can go in turn and pledge, and then just kind of filled out how that works. So I mean, again, in this scenario, the user is deciding, I want to support these particular projects that my code or my service, whether they're an end user or whether, let's say, a company using another service like a database service, they decide what they want to allocate their funds to. Those services they of course depend on other services, or they depend on open source projects. So they choose which ones they want to support, and so on and so on. And this way we can support this vast ecosystem of dependencies that make up the open source world. And again, it's a voluntary mechanism, so it takes away a lot of questions about how to allocate resources. So this is a straw man. Now, of course, again, it only makes sense at scale. And if it's not at scale, then it can't just be one site like us doing it or whatever. So at scale, there needs to be some sort of interoperability. And luckily, and this is again why we're here in this Web3 track. This is like a perfect application for the blockchain. And so imagine imagine open cloud services with these different rights we just talked about, these different licensing rights around data and code, and in turn these agreements around how to spend how to allocate funds. Those agreements, we can come with a standard set of open cloud service agreements in the same way there's a standard set of open source licenses. We've converged on that. Then if those could be encoded as smart contracts on a blockchain, then you can have a mechanism where like users, no matter what service they're using or project or where they're located, can encode their preferences about what they want to support. And then these smart contracts, when the hosting provider essentially agrees, and by agreeing to these service contracts, would put these tokens of how much is being spent through their system of payment tokens on a blockchain, and the smart contract distributes it as per these preferences. And so that's a way we can we could build something at scale. And so so that is all. That's pretty all future stuff. It's so just want to talk a little bit about what we're doing at One Common. So like the very first baby step as we see to build this is to build what we call these reproducible clouds. We call them ensembles. So Unfurl, I'm also giving another talk in the CI/CD track here at FOSDEM today. And this is the technology we've been building to starting point. So the starting point we received is building a way to build a reproducible cloud service. And so basically what these are Git repositories. We call them ensembles. These are Git repositories that essentially know how to deploy themselves onto the cloud. And so they're like Git, so they're shareable, they're decentralized, they're forkable, they can run anywhere. And they're decentralized in the sense that unlike a regular cloud service, the density around the cloud service is tied to where they're located, the URL, the IP address, et cetera, the service they're running on. And their density is tied to around the reproducible state that they're at, which is, just like a commit in Git is like that. And so we're using that to build deterministic reproducible processes to build location independent cloud services that can be moved around. And that's the first step to what we're doing. And that's it. So thank you. So check out our project. Any kind of feedback, what makes sense, what doesn't, we really appreciate. We're an early stage startup. If you're interested in joining us, we're hiring in many different capacities. So please reach out to us and check out our sites. And thank you very much.